So today what we're going to be doing is graphing a quadratic in standard form. Again, but in this case, the quadratics aren't going to be as friendly to graphing as they were last time. This is going to be when we have graphing a quadratic that doesn't have any real roots, which means it's going to curve away from the axis and never actually touch it. This means we're going to have to find the vertex using a different method. We're going to learn about completing the square here in a future lesson, but for today, we're just going to learn two formula which are going to always find us the vertex, given it's in ax squared plus bx plus c format. This means that we're going to have to take x equals negative b over 2a, and remember, this is in the form of ax squared plus bx plus c. So for my b, I'm looking at the second number. For my a, I'm looking at the front number. And remember, if there's nothing there, we assume that there is a 1. Then we're going to plug whatever we get for this into our function, reevaluate, which will give us our y coordinate. Now, this is built off the idea that if I were to try and hand factor this, I would be having to come up with factors of, let's see, negative 9 times negative 1. So negative 9 times negative 1. That would be positive 9. I need to find factors of positive 9, which means sum, that add up to 6. So I have 1 and 9, 3 and 3. Lo and behold, we have 3 and 3, which means that we have, cool, so we can actually factor this one. Let's go ahead and factor it and see what we get. Well, when we factor this one, I'm going to split this into negative x squared minus 3x minus 3x minus 9. In this case, I'm going to pull out negative x, and I'm going to pull out negative 3. So negative x, negative 3. And that's going to give me, let's see, if I divide that, that's an x plus 3. And same thing over here, x plus 3. Ooh, which means I can pull out an x plus 3. So I have x plus 3. And then I have a negative x minus 3. And we know basically that we're setting both of these equal to 0, which means my x plus 3 has to be equal to 0 for my root 1. And my negative x minus 3 has to be equal to 0 for my root 2. I subtract 3. Boom, there's my first root. I add 3. And I divide by negative 1. And we run into our problem. When we try and graph this using the root method, which means we're not graphing the vertex, I end up with the same root. So 2, 3, negative 3, and negative 3, which gives us a problem because that means that that root is our vertex. This is going to curve away from the axis, and we don't know whether or not it's going to curve up or curve down, or how it's going to curve, where it's going to curve, what's going on. So the only way that we can figure out another point to plug in there is we could try and plug in our y-intercept, which means I can take 0 and plug that into the equation just to give it a second point. And so let's give that a shot. So I'm going to plug in 0 and say f of 0 is negative 0 squared minus 6 times 0 minus 9. It's going to be f of 0 is equal to cancel, negative 9. Okay. Seeing as I can't fit that on there, I'm going to make my y by 2's. My x, it's got to be by 1's, which means that's going to be 2, 4, 6, 8, 9. Awesome. And that means that the magic of this is that if I were to draw my axis of symmetry through here, we know that that reflects So there'd be another point 1, 2, 3 to the left that would curve through there. And what we're going to see is that our new approach is going to be a little less cumbersome than this. We're just going to find the vertex and we're going to find the y-intercept. Let's see how easy it is to find the vertex of this same problem. And we're going to do that over here. So I'm not actually going to be doing this problem. I'm going to be resolving number 1 using our new process. So I'm going to find the vertex using negative b over 2a. So negative b over 2a. What is my b? Well, negative 6. What is my a? That's negative 1. So negative negative 6 is 6. 2 divided by negative, or 2 times negative 1 is negative 2. 6 divided by negative 2 is negative 3. Hey, so far so good. So I found the x part of my vertex. Let's find the y part of my vertex. And to find the y, I plug in my x, which means if we remember evaluating a function, I'm going to plug that thing in to the function. So I'm going to say, okay, f of negative 3 is equal to negative minus 6 minus 9. And I'm actually going to plug in a negative 3. So I get negative 3 squared, which is 9. Negative 3 times negative 6 is positive 18 minus 9. 18 minus 9 is 9. Negative 9 plus 9 is 0. So that means my vertex is at negative 3, comma 0, which would put us right back at that spot. And we can see that this relies on a little less, how should we say this? A little less of a cumbersome approach. This is much cleaner because many people just like the simplicity of let's find the x and plug it in. When we factor, albeit the factor will give us the zeros, if we just want to graph it and find where the maximum point is, let's just plug it in and find the vertex. Once we find the vertex, the second follow-up is we do the same thing that we would do right here, and we would plug in our 0 to find our y-intercept. And we would get f of 0 is negative 9. And we graph that. So like I said, if you like a cleaner approach and you need to find the vertex, you need to find that maximum point, most importantly, go for there. Because we lucked out and this happened to be able to be factored. So let's try the new approach on number 3. Let's find the vertex and then the y-intercept. So to find my vertex, I'm going to say x equals negative b over 2a. My b is 6, my a is 1. So negative 6 over 2 times 1. It's going to give me a negative 6 over 2, or again, I get another negative 3. Let's see where this goes. So I'm going to take that and I'm going to plug it into the equation. F of negative 3 is equal to order of operations. Negative 3 squared is 9. 6 times negative 3 is negative 18. 9 minus 18 is negative 9. And this is 0. Oh, so this looks like it might be another reflection of what we just did. So let's plug in the negative 3 and see where we go. So I have my point right there. I know that's my vertex, which would have saved us a lot of time right here because we would have gotten 2 roots again of the same thing. But I found my root, or I found my vertex. Now what I'm going to do is I'm going to find my y-intercept as a second point that I can graph. So f of 0 is, let's plug in my 0 into everything. 0 squared, 0, 9. Boom. Again, I'm going to have to do this by 2's, which means it's right there. And I know the fact that it's going to reflect across my axis of symmetry, which means there's another point right over there that's going to curve through. So if I curve up to the right, I'm going to curve a mirror image to the left. Like I said, there we go. And so because this touches the axis, we'll actually be able to factor this. Anytime this touches, you're able to factor it. So let's try it on this one. This one might not be so lucky. So what I want you to do is I want you to pause the video. I want you to try the new approach and unpause it when you're done and see how you did. Okay, let's give it a shot. So with this one, I'm looking at this and I see factors of 14. I can't find any factors of 14 that would sum to 6. So I know there's no possible factors, which means that this is either going to be irrational or it's not real. So let's try it out. So x is negative b over 2a. And so my b in this case is negative 6, and my a is negative 1. So it's going to give me a 6 over negative 2. I get another negative 3. Really need to change up these questions a little bit. But regardless, I'm going to plug in my negative 3 into my function and evaluate it. That's going to give me negative 3 squared is 9, so I have a negative 9. Negative 6 times negative 3 is positive 18 minus 14. Let's see, negative 9 plus 18 is going to be 9 minus 14. 9 minus 14 is negative 5. Okay, not too bad. But now, what we've seen in the previous ones is that when I graph this point, my other point bounces off my graph. So I'm not going to graph my vertex just yet until I find my y-intercept. So let's go ahead and find the y-intercept by plugging in 0. So if I plug in 0, cancel, cancel, f of 0 is negative 14. Ooh, I'm very glad I didn't, because that means that I'm going to have to stretch this just a little bit. Let's do this by 3's, and heck, why not? Let's do this by 3's, just to keep it even. So if my vertex is at negative 3, negative 5, negative 3, negative 3, 4, 5, it's right there. And I now have another point at 0, 3, 6, 9, 12, 13, and 14. 14. And I know that if I reflect through this central line, that means I have another point right on the other side. And that will curve like this. Perfect. Now, so yeah, if we tried to factor this, it doesn't touch the x-axis at all. We would have been waiting a very long time to find some combination of numbers to find when this crosses the x-axis. So this saved us some time. Let's do one more. So here, I'm looking for factors of 8 that add up to 4. I have 1 and 8, which add up to 9, and I have 2 and 4, which add up to 6. So I don't have any factors. So I'm going to have to use the other method. Which means I'm going to have to plug in my negative b, which is 4, my a, which is a 1. So if I have a negative 4 over 2, negative 2. Hey, we got something other than a negative 3. Progress. So let's plug in that negative 2 and see what we get. Plug in the negative 2. That's going to give us negative 2 squared is 4. 4 times negative 2 is negative 8, plus 8. I know those cancel out, so it's just 4. So there's my vertex, negative 2, comma, 4. And then as we did earlier, we're going to go ahead and we're going to plug in our y-intercept, just so we can have some sense of scale. Cancel, cancel. So my y-intercept is 8. So negative 2, 4, and 8. I think I'm going to be able to get away with scaling this by a factor of 2. So for my vertex, I'm going to go negative 2 to 4. And I have my vertex. I know my y-intercept is at 0, 2, 4, 6, 8. And I'm actually going to draw my axis symmetry in green, because I feel like the orange on red is a little misleading. So I know that if I have a point 1 to the right, I'll also have a point 1 to the left. Boom, there we go. And so just like before, this actually doesn't touch the axis. So if we tried to factor that, we'd be waiting a very long time. Okay. Last question. Go ahead, pause the video, try out number 9, and see how you do when you unpause it. Okay, let's take a look. I'm going to assume now, just by the trend we've seen, that factors of 66 are probably not going to add up to 16. But x equals negative b over 2a. We have a better way to do this. So my b in this case is a negative 16. My a in this case is a 1. So negative 16 is positive 16 divided by 2. I get 8. Ooh. And so if I take that 8 and I plug it in, I'm going to plug 8 into my function. See, 8 squared is going to give me 64. 16 times 8, okay. Well, 6 times 8 is 48. 10 times 8 is 80. 80 and 48 make 128 plus 66. I'm going to kind of skip around this and say 64 plus 66. 64 plus 6 is 70. 70 plus 60 is 130. 130 minus 128 is 2. So my vertex is at 8, 2. Now I just need to find where my y-intercept is. And have any of you figured out the shortcut to finding the y-intercept? Well, when I plug in 0, the y-intercept, if you haven't noticed by now, when I plug in 0, it's always going to be that number right there. You notice that every one of our problems, the number that doesn't have an x doesn't get zeroed out. So when you're asking yourself, what's the y-intercept? At least when it's in standard form, it's always going to be your c term. But regardless, we need to be able to fit 8, 2, and 66. So that means I'm going to have to count more than by tens. I'm going to have to count by, let's say, 15s. This is going to be a really messy graph. So 8, 2. So 8 is going to be about halfway. 2 is going to be just barely above the line. 66, okay, so 15 30, 45, 60. It's going to be roughly there. And we know because if we have an axis of symmetry that goes right here, and I have a point on the left, I'm also going to have a point on the right, which is going to make this very narrow and skinny quadratic. And there we go.